Okay, this is an explanation for the week 6 throwback, which is on Lewis structures. So the first thing I'm going to talk about is the number of valence electrons that things have, because the number of valence electrons is really, really important to the Lewis structure. And so as a reminder, it just goes right across the columns. We only really care about the S block and the P block because in the D and the F, things get weird with valence electrons. So we have one valence electron, 2, and then you jump across, and it's 3, 4, 5, 6, 7, 8. All right, and so you just look down the column, and anything in those columns are going to have that number of valence electrons. It's kind of that easy. You'll get the periodic table when you do the throwback, so just kind of try and remember that, and you should be good. Also, as a hint, on your periodic tables, like this one, it says 13, 14, 15, 16. Notice that that's just 10 more than the number of valence electrons that you have there. So it kind of counts it right across the top for you in that way. So looking here, the next thing that we do is we do what's called a Lewis dot diagram. And so CH4 here being the first one, we think carbon, okay, how many valence electrons does it have? It's in column number 4, so it has 4 valence electrons. So you put them around like this. Okay, you can't have any 2 on the same side without having the other ones filled up. And so we have 1 on each side for carbon. Then if you look up hydrogen, hydrogen has 1 valence electron. And so here's the next thing that we do. We have 4 hydrogens here. We're going to orient them so that the valence electron on the hydrogen is pointing toward that open valence electron on the carbon, because that's where the bond is going to happen. Okay, and so we have 3 more of those hydrogens doing exactly the same thing. All right, and that is our structure. This is actually not the final form you're going to want it in, though, so hopefully I've been kind of writing this down as we go along, because in the end, I don't want the dots and the circles. What I want is something that looks like this. So maybe do that work off to the side or something like that, but this is what it will look like in the end. So a circled pair of electrons just becomes a bond. So for the second one, we've got a nitrogen. Nitrogen has 5 valence electrons, so 1, 2, 3, 4, 5. Okay, then we're going to put 3 hydrogens around it. So again, these single electrons are kind of the spots that are open for bonding. So we'll put a hydrogen here, and we'll put a hydrogen down here, and we'll put a hydrogen here, and everything's good there to bond. So we get a bond here, we get a bond here, we get a bond here. And then it's important to note that on the top of the nitrogen, there are 2 non-bonding electrons. There's a lone pair of electrons, and that needs to show up in our Lewis structure in the end. So what we're going to have, each of these circled pairs of electrons is going to become a bond in the end. All right, so we end up with something that looks like this. All right, and that is NH3. PCl3 is very similar. P is in the same column as nitrogen, so it has 5 valence electrons. So we have 1, 2, 3, 4, 5. Chlorine has 7 valence electrons, which means it's just going to have 1 spot that's open for bonding. So chlorine, I'm going to put the pairs on this chlorine on these sides so that this 1 electron on the side that has just 1 electron on it is facing towards the P here so that it can bond. And then we've got a chlorine like that on each side here. So 1, 2, 3, 4, 5, 6, 7. And then another chlorine. And then again, any non-bonding electrons need to show up in the final structure. So I'm just going to change these circled ones to bonds. And then everything else shows up in the final structure. O2 is a little bit interesting here. We've got 2 oxygens involved. Each oxygen has 6 valence electrons, meaning it's going to have 2 pairs that don't bond and then 2 individual ones that are open for bonding. And this one's a little bit confusing, but because of this, that means that each oxygen is going to want to make 2 bonds. And so we get that normal bond here that they make in the middle, but then you get an additional bond that they make between those other electrons. And so this is actually, if you remember, called a double bond. And we get this because each oxygen wants to bond more than 1 time, and they only have each other, so they need to bond twice to each other. And so I'll get rid of these here and fill it in as a double bond between the two oxygens. And that will be good. The next one, HCN. The carbon is going to be in the center here. I kind of tried to give it to you in the way that it's going to be laid out. Carbon's in the center, 4 valence electrons on the carbon. Hydrogen has 1 valence electron. All right, nitrogen is going to have 5 valence electrons. So remember, that means that it's going to have 3 single ones and 1 pair if it has 5. And so what we're going to do is we're going to put the pair on this side opposite the carbon, because all 3 of these are going to want to bond, and the only thing that they can bond with here is this carbon. So it bonds once with the carbon, twice, 3 times. All right, and then we have a single bond between the hydrogen and the carbon. All right, so we'll go through, exchange all these circled things with actual real bonds. And that's a triple bond there between the carbon and the nitrogen. Going on here, H2O. Hydrogen can only make 1 bond, so it's not ever going to be in the center. So we're going to put the O here in the center. O has 6 valence electrons. Hydrogen has 1. Now, with the oxygen, you could have had the single ones on different sides here. I just like it to look kind of symmetrical here, so I put it like this, but you could have the hydrogens attached to different sides of this oxygen if you wanted. And so it looks like that, and we see that those 2 are single bonds, so we're going to replace that with a set of single bonds. And that's what that looks like. HI, hydrogen has 1 valence electron. Iodine has 7. Okay, which means it's going to have 3 pairs and 1 single. And so remember, put the pairs on sides that are not facing the hydrogen, because those can't bond. Okay, we want the 1 single one here facing the hydrogen so that it can form that bond here. Makes HI. All right, we'll erase that. Replace it with a bond. And then this SiO2. So silicon, that's below carbon, and so it's in that 4th column. It has 4 valence electrons. So we have 1, 2, 3, 4 valence electrons there. And then it's got oxygens on either side of it. So here's the deal with this one. Remember, oxygens make 2 bonds, so they have 2 pairs and 2 that are single. That means that each one of these oxygens is going to double bond with the silicon. And so we've got that there. And then this one, it needs to have its single, this oxygen needs to have its single electrons down here so that it can bond on the bottom. All right, and it still has 2 pairs left. All right, and so then we're going to replace all of these circled electrons with bonds. Okay. Keep in mind this is an Si. That kind of looks like a double set of dots there, but that's an Si. And this makes a double bond here. And it makes a double bond with that other oxygen, and that is what we have there in the end. Okay, so I went through that pretty quickly, but hopefully it made sense to you, and if you don't understand anything, you can always feel free to come in and ask. But yeah, that is Lewis structures.